So the next topic which we are going to have is from module 4, which is referred as data intensive computing. Okay. So the topic which we are to cover here in this particular module is data intensive computing. As the name indicates, it's a data intensive computing. So when you start talking about data intensive computing, what you should have is the first question. So what it relates to. So we are doing the computation with respect to the data. So data intensive computation computing is nothing but what? So you're going to computation is done with respect to data. Okay, the computation will be done on data. Okay, so when you are doing the computation with respect to the data, so what it is focused on? Okay, so it's going to mainly focus on the different class of applications that deal with a large amount of data. So, okay, so different applications where you are going to have. So it is going to deal with what? It's going to deal with a class of applications. So you are going to have the n number of applications. With the n number of applications, so what you are going to do? So that particular applications which deal with the large amount of data. So that deal with a large amount of data, you are going to have that one. Okay, that deal with a large amount of data which you are going to have. So now, so there are several applications field which you are going to have. So starting from your computational science and social networking also have. So if you take the social networking also, you're going to have the more number of data is involved there. So if you take the where it produces a large amount of data. So if you take the normal web or Google, so when you are going to request a large amount of data, so it has to be taken from the n number of sources. So the sources may be either of it may be structured data. So what are the data you are going to have? So when you are going to have to process the data, so when you are going to have the process of data, so the processing of the data will be done in a different way. So that is, you may have the structured data. So when you are going to have structured data may be there. So semi-structured may be there. Semi-structured data may be there. So then your unstructured data may be there. So these are the different data which will be there in the web. Okay. So when it is in the web, so what I need to do with respect to that particular data? So in the applications of computational to social networking, where the large amount of data is generated. So when it is generated, so what I need to do with that particular data? So I need to efficiently store that particular data. So whatever the data you are going to have, so that data, so that the data generated, what I need to do with that one. So if you have the data, so data is generated. So what I need to do with that particular data? So what I need to do with that particular data? So now I want that particular data in the future. May I require that particular data in the future for some purpose? So if I require that particular data to be required in the future, so I want to do what? I want to efficiently store that particular data, right? I want to efficiently store that particular data. So once you have stored that particular data, so how we are going to make? So once you have stored the data in your large number of data which is there, so now what I need to have? So I need to have to made accessible of that particular data. So I have to make accessible that particular data. So made accessible is one thing which I have to keep in your mind. So made accessible for that particular data. So when you are made it accessible, so how I am going to make accessible that particular data? So because when I'm retrieving, so when in the web, when you are retrieving it, so even if you take your normal system where you are going to store the data, so it will be indexed internally. So if you've gone through the file system in your operating system, how the files will be stored. So all the files will be having indexes. With the help of the index, it is going to store that particular data in that particular memory. So here also, when it is storing in the web, so it has to be indexed. So what I need to do now, so the data has to be indexed. Okay, the data has to be indexed. So next, once these particular data are there, so I have the data. So with the data, I'm going to store that one. So whenever I require that one, I'm going to access that particular data. And to access that particular data, I'm going to index that particular data. So now, when you are going to have that one, so for what purpose you are going to need that particular data? So I have that particular data to analyze it. I want to make that particular use that particular data to analyze in the future. Okay. So there are a number of, so when you're talking about the distributed computing, So there's many challenges which you are going to have in your scalable and distributed architectures. Okay, so when you are going to have the scalable and efficient storage architecture should be there, and you should have the better performance should be there. So better performance has to be there in terms of what? So in terms of your data computation and processing. So when you are going to have the performance, so all the data I'm going to have. So now I want the performance of, so how I need to have the data. So performance I have to calculate with respect to what? The performance has to be calculated with respect to your data computation and with respect to your data computation and processing. So I require the data for your data computation and processing. Now these are the things which the data is required. So intense computing should be there. So when you if you start talking about your parallel and distributed techniques, so here what will happen? So there are several problems which need to face. So what are the problems I'm going to have is this particular data is the next question. So what are the different problems you are going to have with respect to the particular data? I have the data, so I want to represent that particular data. So the first problem you are going to have is data representation. I have to represent this particular data. So data representation should be there. So next, once you have the data representation, if I want to have the performance to be calculated, so I want to you make use of the efficient algorithm. So I want to make use of the efficient algorithm. Okay, so I have to make use of the. So next, whenever I'm going to, if the storage is exhausted, for example, I'm going keeping my, for example, in your laptop only, for example, I'm telling. So if the 1 terabyte of hard disk which you are going to have in your laptop or in your desktop, if it is exhausted, that means if it is completely filled, what I need to do, I have to enhance my storage now. So here also, if your data is keep on adding to the hard disk, so at one or the other day it has to get full, right? It has to get full. So once it is done, I have to increase that one. But in real time, who has to do that one is the next question. So you should have some features which is infrastructure which has to provide all these features, which is nothing but your scalable infrastructure which should be there. So it should have some scalable infrastructure which has to be there. So now, depending upon all these parameters, which is a basic requirement which you are going to have with respect to data computing. So we come to one point to define what do you mean by data computing. So what is the purpose of using the data computing? So here, if you start talking about your data intensive computing. So why I require data computing is the next question. So if you take the data intensive computing, so what it is going to concern about mainly. So if you start talking about data intensive computing, so data intensive computing is mainly concerned with production. Okay, what production? Data production and manipulation of the data and analysis. So these are the main three words which you need to know. So first is production, you should have. Next is manipulation and analysis. So you're going to have these three words. Okay, so you're going to have this one. So there is production, manipulation, and analysis. So you're going to have the manipulation and analysis of what? Of large scale data in the range of 100 of megabytes to petabytes and beyond. Because all this data is available in the net. Okay. So for example, if you take your Facebook or if you take your Instagram or if you take your Twitter or some of the social networking websites where the data is residing. So when the data is residing, I have to that will be producing instantaneously, because whenever someone is uploading the image will consume some space, right? So now when the image is consumed some space, what I need to do with that particular space? So that particular space will be exhausted. So now one or the other day that particular space has to be uh, gone, so that I have to allocate some other resources to add that particular storage. Okay, so your data intensive computing is mainly concerned with what? Three main things. One is the production of the data and the manipulation of the data and the analysis of the large scale data. So what is the size of the data which you are going to have? The size of the data which will be in the range of megabytes to petabytes and beyond. So now, what do you mean by data set? So next comes the question, what do you mean by data set? So now, the main term data set is commonly used to identify a collection of information elements. So it is the data set is nothing but what? It's an array. So data set. So as the name indicates, data set. What is a set? A set is a group of element. Okay. If you take the set, a set is nothing but the group of element. Okay, which will be there. So but depending upon the some predefined rules or some predefined parameters which you are going to have. So like if you have the set of some number of even numbers set, odd number set, like that it will be there, right? So similar to that one, if you take the data set, so the set is nothing but a collection of element. So now here data set is nothing but what? It's identify a collection of information element. So the term information, what it suggests, the some information it suggests that it is carrying some information. Okay, so the information is going to suggest that so it is carrying some carrying some meaning. Okay, it is that particular data is carrying some meaning with respect to what that particular data set is carrying some meaning with respect to application, with respect to one or more application, that particular data set is carrying the information. So now whenever you are going to have the data set, so they are oftenly maintained in repositories. So that means whatever the data sets you are going to have, so that will be stored in one place. So which are infrastructure supporting the storage, retrieval and indexing of large amount of information. So they are going to be maintained in repositories, or it is going to have the rack of servers will be there, or rack of storage space will be there in the data center. So data centers are the place where the more amount of data are stored. So now it should have the repository. So with that repositories are nothing but the infrastructure. That repository is nothing but the infrastructure. So what that particular repository or infrastructure that has to support? That has to support the storage of the data, retrieval of the data set, and indexing of the large amount of information. Because when you want to retrieve the data from the big database, so it may take time, right? So that is what it is going to have. So if it is nothing but what? So if you're in a room, for example, if you have a room and you have a cupboard and you have assume that you have around 10 cupboards. In the 10 cupboards, you are going to place all the files. Now, if you are that is nothing but your storage, what you are doing. Now, how to locate that particular file you are going to have? So I will give a number for that particular file, right? So that number, what you are going to give to that particular file is nothing but the indexing. Okay. So now, why the indexing is useful? The indexing is useful at the time of the retrieval. Okay, so the indexing will be useful at the time of the retrieval. So now if I am keeping the file inside your rack, depending upon the number, so assume that you are going to have 10 different almirahs are there where I am going to keep the file. So in the first almirah, I am going to keep the file from number 1 to 100. In the second almirah, I am going to keep the file numbers from 101 to 200. So like that, I'm going to keep all my 1000 files in the 10 different almirahs. So now, since I have given the index for that particular file, what will happen is if anybody asks you to bring the file number 920 or 930, so you can go to the room and you can fetch that particular file from the rack number 10. So inside that rack number 10, I will search for the file number 920 and I'm going to retrieve it. So if you are not done the indexing, what will happen? So I have to search the entire 10 files. I have to search the entire 10 different cupboards. So that's the problem what you are going to have. So that is what you are going to make use of this one. That is where you are going to make use of, sorry for the disturbance. Okay, that is where you are going to make use of this particular storage. Okay, so in order to facilitate the classification and search of relevant bits of information, metadata are attached to data sets. So that means what? Metadata is nothing but data inside the data. So if you want to have the classification and the search of the relevant information, so assume that I have the image. So if I have the image, so now I have to name that particular image. For example, cloud related image. So now when you are searching in the Google, so in the Google cloud related, if I specify only cloud what, so cloud means what? It may give you the image of the cloud also. If it is not knowing that you want to search the cloud which is related to the technical term. Okay, so now I should have some data inside the data with technical term. Okay, the cloud with respect to the technology is different. The cloud with respect to the outside environment is different. So in order to have the relevant image has to be retrieved. If I have to retrieve the relevant information, what I should have, so I should have some other information embedded inside that particular image, so that the appropriate image has to be retrieved. So instead of cloud, I will tell cloud computing. So when the computing comes, so that will be the keyword. So cloud is going to have the data inside the data is computing. So whereas you are going to have the computation you are going to have with respect to the cloud technology. So now it will retrieve the images from the different sources. So you can see it from the Google only, right? So if it is only the cloud, so all of you have searched, I think, right? So just for your example, I will show here. So just if you open the Google here, okay, if you open the Google, so in the Google, for example, if you have only cloud, so I will give only cloud. So I will not give anything. So search I will go. So when you are going to have the cloud, so Google Cloud is there because that is the number of that is. So it is retrieving depending upon the type of the searching mechanism or which one is most accessed. So that was depend upon that one. Okay. So now you can see it here cloud. So if I'm checking the images, it will you can see that what is the cloud related to the environment it is showing here. Okay, what is the all the cloud, but it is not giving any information about the cloud technology, right? So now if I tell cloud computing, okay, cloud computing, I'm going to click. So now it will give the images with respect to the cloud computing, right? So now your computing is what you are computing, what you are giving is a metadata, right? That is data inside the data. So that will give you whatever the cloud technology we are going to look into. So that is what your metadata refers to. So that means you are going to classify and search the relevant bits of information where the metadata are attached to that particular data set. Okay. So that is how the data intensive computing is going to work. So when it goes to the next one, so data intensive computations occur in many applications domain. So where you are going to make use of this particular data intensive applications. So it is mainly used in computational science where more number of computations are required. So next scientific simulations where it is required, and bioinformatic applications is required, and where you are going to have the earthquake simulators process, where the earthquake simulators we are going to have, where it is going to process a massive amount of data. So there you are going to have. So now, so then whenever you are going to have the scientific simulation and experiments, they are often keen to produce, analyze, and process huge volumes of data. So if you take the earthquake simulators, or if you talk about your uh, scientific simulations, if you take the scientific simulation, so you can see it here. What will happen here in the scientific simulations? If you take so scientific simulation, so what it contains. So if we talk about the scientific simulation experiments, so there it is often keen to produce data. So your scientific experiments is going to produce keen to produce, analyze, okay, analyze and process huge volumes of data here. Okay, and process huge volumes of data. So that's what the scientific simulation is going to do. So now what it is going to do there? So it is going to do that in the scientific, it is going to keen to produce, analyze, and process huge amount of data. That is in your scientific simulations. Okay. So, but that is not the case with your biometric applications. So if you take the biometric applications, mining database, so that contains terabytes of data. Okay. So that means if you take your normal Aadhaar card only, so there's biometric is there. So with the help of the bioinformatics, biometrics, so you're going to retrieve that particular person's image like that and all. So next is earthquake simulators you are going to have. So in the earthquake simulators, it processes a large amount of data. So what it is going to process a massive amount of data. So the data which has been produced, it will be as a result of recording of vibrations. So you are going to have the vibrations on the earth. So whatever the vibrations you are going to have on the earth, so that particular vibrations it is going to take as the data across the entire globe. So because so the vibrations will be happening. So if it is normal vibrations, then you won't sense anything, right? So now if you are not sensing anything, so obviously what will happen? Nothing harmful is going to happen. But if the vibrations are too heavy, obviously it's going to harm the things. So then we have to be careful at that time. Okay. So next, when you're going with the data intensive applications where they are being to be used, so that data intensive computations is mainly used in the social networking and gaming, are two sectors where intensive computing is now a reality. So in your social networking, when you want to have the more number of images to be there in the Facebook, more amount of image will be posted. Or if you take the LinkedIn, so where whichever the social platform are there, okay, whichever the social platform are there, and the gaming. So in the game, game will consume more amount of data. Why? Because the resolution what you require to play the game has to be high. So when the resolution has to be high, it has to play the video also high. So when you're going to have the video, so when you're playing, for example, if you take the PUBG only as the example, so when hundred of people are combined together and are playing on a single device, then it is going to accommodate more, then it is going to generate more amount of data there. Okay, so then you are going to have the computation with respect to that one will become more important. So next is Facebook inbox search operations. Okay, so now when you are going to have the Facebook inbox, so what will happen? There you are going to have the more amount of search operations. So that is nothing but you are going to have to crawl about 150 terabytes of data. So according to the textbook when they have written, so they have told that around it is 150 terabytes of data. But now it has gone beyond that one. So it is more like, so this particular textbook is written 5 years back. So this is 5 years back the textbook has been written. So at most 5 years that the data size also be almost it will be doubled or tripled. Okay, because the more amount of data is generated in the world. So now when you are going to have more amount of data, and the whole uncompressed data stored by the distributed infrastructure reaches to 36 petabytes. What it is going to tell. So you're going to have the terabytes. So once you have the terabytes, so next all these terabytes which you are going to have that will be combined in the different data centers, okay, different storage device which is in uncompressed data format. Because when you want to retrieve some data, so the information what you are going to retrieve, it should be in uncompressed form only. Okay, so when it is in uncompressed form only, you can retrieve the data faster. Okay, you can retrieve the data faster. So for that particular reason, so the uncompressed, so when you are going to have the different uncompressed data which is stored all across the globe in the distributed infrastructure, it will be reaching to 36 petabytes. Okay, so now, so when you are going about the terabytes, so it will be in the power of 40. So 2 to the 40th power, or 10 to the 12th power, which equals approximately trillion bytes. Okay, so we have the precise. So if we talk about the terabyte will be approximately equal to your 1000 gigabytes. Okay, 1000 gigabytes it is going to have. So 1 TB. So here we are telling about 150 TB. So even though 150 TB is not sufficient, because when you are doing with respect to computation means what? So the more amount of data will be generated. So for example, if I tell, so as I told the same example again and again, I have to repeat it. So whether you people have remembered it or not, I don't know. So when you talk about the Gmail, so Gmail is giving you how much space? It is 15 GB. So for example, I'm telling. So in the class, they are going to have 60 people. So if it's the first 60 people, if they are providing 15 GB, then obviously the total size required to use Gmail account for the entire class is 900 GB. So that is almost equal to 1 terabyte now. That is your 900 GB is equivalent to the 1000 GB. 1000 GB is almost equal to 1 terabyte. Okay. So that's where you are going to make use of. So if it is 1 terabyte is required to have the Gmail account for your own class. So in the department, there are around 10 classes are there. So in the 10 class, out of for the 10 class, it requires 10 TB. So when the cut comes to the college, it may require around 10 20 TB. Okay, so it is of one college, I'm telling. So there are a number of colleges are there. If each college requires 25 TB of space, so obviously inside in near the colleges which are vicinity to the Lanka, it will require around 200 to 300 terabytes of space which are going to have. So other is Zynga, which is going to have the social gaming platform. So it moves 1 petabyte of data daily, and it has been reported to have 1,000 servers every week. Because when you are going to have the gaming platform, more amount as the game um, as the game is advertise properly, more number of users, more number of people are going to play that particular game. When the more number of people are playing that particular game, obviously, so the number of servers has to be increased to accommodate that particular speed and the computation what it has to be done. So it has to sustain the growth, store the data generated by the games. So these are some of the data intensive research issues which you are going to have. What are the different issues which you are going to have in your data intensive research? So first is your heterogeneous form. So heterogeneous format, because in the web you are going to have the n number of data. Either it may be a structured data, or it may be a semi-structured data, or it may be a unstructured data. So now, whenever you are going to have, so volume of data I have to take into consideration, and you are going to have the format of consideration has to be taken into account. Okay. So now, when you are going to have this particular amount of data which is there, so I have to see that what are the current problems which are facing. Okay. So if you take the x dimension and y dimension, so your y dimension will tell what are the different problems we are going to face. So we are going to have the non-homogeneous format, that is the same type of information you are going to have. So homogeneous, and it will be in non-distributed megabyte. It will be in terms of megabytes or gigabytes. So if you have the homogeneous format. So now, if you taken the data completely, so if you take the data completely in terms of with respect to the volume or format or distribution, so then it will become to the heterogeneous format. Okay, then if your data is only homogeneous problem, so it is going to have some problems which you are going to have is compute intensive problem. That particular problem is referred to as a compute intensive problem. So now, when you are going to take the data, complete data you are going to take, that means the data may contain either structured data or unstructured data or semi-structured data. So then whatever the data you are going to have, it will be in the heterogeneous formats. So I don't know in which form it is the data is there. In heterogeneous format, that particular data will be there. So then whatever the problem you are going to face, that will be data intensive. The problem what you are going to have in that particular heterogeneous format is referred to as a data intensive problem. So for that one, you have to do the data or compute intensive problem. So when you go to this particular dimensions, so more model server simulation will be there. So compute intensive problems you are going to have, and data or compute intensive problems you are going to get. Okay. So this is going to provide you the statistical model or decision support this knowledge representation which you are going to have. So this particular part you are going to study in your big data analytics and machine learning. Okay, that will be separated. That way you are going to study as a separate subject in your next semester. Okay, so here you are telling only about the basics of your data intensive computing. But your cloud computing, that is in the cloud computing, how the data is to be represented, how the data has to be computed, and how the accuracy has to be obtained. So how the accuracy has to be obtained. So that has to be taken care in where, that has to be taken care in your some of the machine learning algorithms. Okay. So next, what are the different challenges in data intensive computing is going to face? What are the different challenges we are going to have? So now we are going to have the scalar algorithms. So there are some of the algorithms are there, right? If you take the machine learning, that there you are going to see that particular algorithms, and you are going to study those algorithms. So those who are in your data mining algorithm, they will be knowing clustering algorithm is there, a priori algorithms are there, and k nearest neighborhood KNN algorithms are there, and reinforcement learning are there. Because if you take the data is generated dynamically. So for every second, around 1000 GB of data or 1 terabytes of data are being generated. Okay, so to have to analyze to in that particular data, if you want to search and process that particular data, you should have some scalable algorithms. So you should have an algorithm which should have a scalable algorithm that can search and process massive data sets. Okay, so that is one of the challenges you are going to have. So still now, so it is having some limitations that if the data set is this much, I can efficiently retrieve the data and I can process the data and I can analyze the data. But if it is going beyond that particular data, the searching itself will become more time, right? So when the searching itself will become more time, then I should have more efficient searching algorithms. Okay, more efficient scalable algorithms or searching algorithms, which has to be required for searching and processing that particular massive data set. Okay, so now once you have done, so as I show you that cloud, if I give the cloud, it will retrieve certain image. Okay. But when you tell cloud computing, it is going to retrieve the image with respect to the cloud technology, right? That I have shown you as an example. Now, you have what by incorporating what you have retrieved the proper cloud computing figures by incorporating the metadata. So there the metadata is nothing but computing, right? So that is data inside the data. Okay. So now when you press the that data inside the data is called as metadata. Okay. So that particular metadata is going to tell you that what you have to retrieve it. So you have to have some new metadata technologies. Okay, new metadata complex management technology should be have that can scale to handle complex, heterogeneous, and distributed data sources. Okay, so it has to handle whatever the new metadata management technologies it is going to have. So that has to scale to handle complex, heterogeneous, and distributed data sources. So it should handle both complex data set. It should have the heterogeneous data set. So heterogeneous data set is nothing but what, so it is going to have a different structure. Either it may be structured data, different types of data it is going to have. Either it may be a structured data, or it may be unstructured data, or it may be a semi-structured data. So you know the difference between your structured, unstructured, and semi-structured, I think, right? From your database management system. So then, and you should also have the metadata management for your distributed data sources. So if we talk about the distributed data source, the data is source you are going to retrieve is not in a single place. It will be distributed all across the globe. Okay, it will be distributed all across the globe. So now, so that is what you have to have the proper mismanagement techniques. One is scalable algorithm is should be there. But for what for you should have the scalable algorithm to search and process the massive data set. Next, second one, you should have the new metadata management technology should be there. So what purpose you should have the metadata management technologies to handle complex, heterogeneous, and distributed data sources. Okay. So now, once more and more processing system has been incorporated. Okay. So now when you are going to have the more high performance computing platform, so what it has to provide, so it is aimed to provide a better support for accessing in-memory multi-terabyte data structures. Okay. So it has to support the accessing in-memory multi-terabyte data structures. So data structure is nothing but what? When you talk about the linked list, how the linked list will be, in the linked list, how the data will be stored. So data will be stored with the help of the link, right? So because the address of the next node will be held by the previous node, and the if it is a doubly linked list, both at the front end as well as the back end, it is going to have the address, right? So that is one where we are going to make use of. That is, if we are going to make use of the data structures. So it is going to provide, or it may have the tree. Either you can have the tree structure where you are going to have the root node. So to the root node, depending upon the different conditions, so you are going to connect the branches. Okay. So depending upon the different conditions. So if you take the tree, for example, there may be a tree. So under the tree, you may have structured, unstructured, or semi-structured. So under structured, what are the different types of data you are going to have? You can differentiate and you can access that particular better support by that one. So that is what when you are going to have the high performance computing platform. So it is going to better provide support for accessing in-memory multi-terabyte data structure. Okay. So whatever the high performance computing you should have, it should be highly reliable. What do you mean by reliable? When you are going with the performance, so whatever the data you are going to retrieve, it should be proper data. Okay. So or it should be in petascale, distributed file systems. Okay. And these data generation, signal generation techniques for data reduction and rapid processing should be there. So that is data signature generation techniques. That means what? So I should have the signature inside the particular data. So when you are going to have the signature inside the particular data, as I show you in the figure, cloud. So it will, if it is a cloud, it is showing, it is retrieving the different types of cloud. It will show the environment cloud which is there and retrieve that particular image. If I am telling cloud computing, it is going to retrieve the information with respect to the cloud technology. So now, what made that particular information has to be retrieved? So either it may be due to the metadata or it may be due to the data signature. I can give the name for that particular data. So if I give the cloud computing images, so then it will retrieve the data from that particular part. Okay, so which is where the data signature is referred as cloud computing. So wherever the technology is involved with respect to the cloud computing and the images related to that particular technology, it is going to retrieve from there. Okay, it is going to retrieve from there. So for that particular purpose, you require the data signature. Okay. So that data signature generation technique should be there for data reduction and rapid processing. So that means if the signature is there, obviously it is going to retrieve the proper images. If it is retrieving only the limited images, so obviously the reduction of the retrieved image is less. Okay, data reduction is going to happen. Once the data is less, the processing of data will become speed. Okay, the processing of the data will take faster. That is nothing but nothing else. So I say simple that calculate the, if you tell, calculate the average of HM students. It is specific. I'm specifying the signature there. That means you should calculate the average of the HM. Instead of that one, if I tell simply that calculate the average of computer science, then it doesn't matter. So there the data is not reduced, right? So then I have to calculate the entire semester's calculation I have to do, and all the semester's calculation after that one I have to reduce it and I have to process it. So that will take time. So if you don't have that one, if I have the data signature generation, so then obviously it will reduce the time for that one. Okay. So now if I tell only if I don't have the class name, if I'm not giving the class name as ATA, so now if I tell only calculate the average of the HM A section students, so if I don't have the class, what I need to do, I need to go to the exam section. I have to collect the USN number of all the people who are there in the section, in that particular section, and I have to go and collect the I have to collect the result of that particular people. And after taking the result of that particular people, you are going to calculate the average of those people, right? So that is going to take time when you don't have the data signature. So that is what the same thing which happen in your data reduction also. So whenever whatever you are going to face with your real-time world, so that you keep in your mind. So now there are some of the new approaches are there for software mobility for delivering algorithms, which is able to move the computation where the data is located. So now there are some more amount of software mobility is there. So what that particular software mobility is going to provide you that. So it is going to deliver the algorithms, and it is going to able to move the computation where the data is located directly. Okay. So there are specialized hybrid interconnection architectures are there. So which will provide you the support for filtering. Okay, which will be providing the filter for support for filtering multi-gigabyte data streams coming from high-speed networks and scientific instruments. Okay, so what it means, so it is going to have the specialized hybrid interconnection architecture. Okay, it's going to have the specialized high-speed interconnection architecture. What it is going to provide, so that is going to provide you the filtering the multi-gigabyte data streams. Whatever the data stream it is coming, so it is going to be filtered. Okay, the multi better support for filtering the multi-gigabyte data streams. From where it is coming, so it may be coming from high-speed networks, or it may be coming from scientific experiments, or it may be coming from some other sources. Okay, so it is no need to be in the high-speed network or scientific instruments, because n number of data are generated in the different forms in this particular world. Okay, so even as in the social media, when you go, what will happen? I will create my own image and I will post it. So I have some image, I will post it so that others will take that particular image and they will repost it. So when they're reposting it again and again, so the same image is taking the multiple copy. So if you're going on keeping the multiple copy, what will happen? The size of the storage space also get increased. So that has to be reduced. So to reduce that one, I'm going to index that particular image. If you are using the multiple copy of the same image, okay. If you are using the multiple copy of the same image, I am going to index it. So with the index, if when you are copying and if you are pasting that particular image to the other part, so what it is going to have? So it is going to take the index and it is going to use that particular index that you have sent in your WhatsApp. How many of you sent that one in your WhatsApp? That if any image is sent to you people, so if you are now if you are used that particular image and if you have deleted that particular image, for example, so if the source person who has sent that one, if he has deleted in his image, can you retrieve that particular image again if you have deleted in your system? No. So if it will ask for the other person to store that particular image in his location. So that is how why it is happening like that in your WhatsApp, because the indexing has been done with respect to the source. Okay, the indexing will be done with respect to the source from where you are getting that particular image. So that's what you are going to have to think. So why that is happening there. So these are some of the challenges which you are going to have. So they should have some high performance software integration technique should be there, which will be facilitating the combination of software modules running on different platforms to quickly form analytical pipelines. Okay. So software integration should be there. So whatever the software integration techniques which you are going to have, what it is going to, what it should facilitate, it should facilitate the combination of software modules on different platform. Okay. So that means the software module which will be running on Mac is different. The software module which you are running uh, in your Linux operating system, it may be different, and the software module which will be accessing in your Windows operating may be different. So now may have to make use of the analytical pipeline, and you have to retrieve that particular images, and you have to make use of that particular data for your analysis purpose. Okay, for your analysis purpose. Okay, so these are some of the challenges which you are going to have with respect to data intensive computing. So when it comes to the historical perspective, so this you read it by yourself, historical perspective, because so when it come out in the historical perspective, so data intensive computing involves the production, management, and analysis of large volumes of data. This I have told already. So it should also support for data intensive computations is provided by harnessing storage, networking technologies, algorithms, and infrastructure. What I have told previously, the same thing. So in the early age, they are going to make use of the wide area networking. So after that one, to support the data storage, they are going to make use of data grids. After data grids, they are going to make use of the data clouds and big data. So next, now with the help of with the data which is stored in the data clouds and big data, they are going to have the databases. And if you want to analyze for some operations, you should have some database and data intensive computation. Okay, computing should be there. So what do you mean by data grid? It has been explained. So I will go with the data grids in tomorrow's class. So anybody having any doubt with respect to the big data, you can ask if you have any doubt. Because this particular part is very interesting. If you are if you are comfortable with your database. Okay, so if you are comfortable with your database, this particular part is very interesting, because the same thing you are going to carry, this particular part you are going to carry in your next semester in your machine learning as well as your big data analytics.